Hey guys, you know how I made a video about springs last week? I'm going to make another one this week, but I've gone way further this week, beyond what is probably necessary, but it's been a really good way of getting into Fusion and understanding parametric design better and all these things that you can do in Fusion, which you can do in other CAD programs that I'm familiar with as well, but it's been really good to use something that's relatively simple like a spring to understand a bit more about different environments in Fusion and what the current limitations are and what I can expect to get out of it. So last week you would have seen that I had a relatively simple way of making a relatively accurate spring. And by all means, if you want to make something for presentation purposes only and you're going to buy a spring off the shelf and have it do that job, and you just want something that's in there that looks pretty accurate and will do the job, I fully recommend still using that method that I talked about last week. So that's what's shown on the screen at the moment, the kind of thing that you can expect to get out of just a few coil commands and some relatively simple maths. Probably takes about 2-3 minutes once you get good at it to generate something that looks pretty accurate for a closed and ground spring. But I wanted to go a bit further. I still am holding out for being able to animate springs compressing without doing weird cuts and joints and stuff. Have them actually regenerate on the fly. But yeah, so this is sort of the path of investigation that I went down. So right now there's actually 3 ways that I know of to get actually kind of 4. So if you count the way I did last week, actually using the coil command, that's one way of generating this sort of geometry. Another way would be to use a coil and then you extract the 3D geometry from that line that appears on the outside, and then you use that to do a sweep of whatever shape that you want. And now until very recently, I think, it was December, if you did that, you had no control over where the profile stayed on that line, so you ended up with a mess, really, really ugly helical geometry. But that's fixed, and I'll cover that in a second. So first way is use the Helix command, as we did last week. Second way is extract the geometry from your helix and then use some other profile to make your helical geometry. The third way is an app that sits on AutoDesk's website, which you can download and install, and it's really, really easy to download and install. It's completely clean on the install, and you don't need to go into your C drive or anything like that to make it work. But it has some limitations in that. Oh, by the way, when you're on this page, you can't click here to do the download. And I was operating on half screen when I did this, and I was clicking here and being frustrated about not being able to download it. But if you go to full screen, then you got a download thing over here. So I know no one's going to be as dumb as me on that regard, but top tip. So the limitations of this are that you can't select the plane on which your helix is perpendicular to, which is a hassle. And the other thing is you can't choose how many points the helix is interpolated between. So that's these black dots that you can see there. You have no control over how many of those it creates. So I guess for some things this would probably be fine and easy if you're worried about dragging and dropping folders that will then be associated with tools and stuff in Fusion, but really it's not that hard. The other way to do it, which I recommend, is actually use the tool that's recommended not on the Autodesk site, which is the Autodesk App Store, but what's recommended in their update video, which is what's new in Fusion 360 December 2007 update, 17 update. They give you a GitHub address, which is interesting that it's on GitHub and not on their site, yet they recommend it. So yeah, go to this GitHub site. It looks like this. You download a folder. There's a tutorial on YouTube about where to drag and drop the folders and stuff. I had to restart Fusion to get it to pick up that tool. but yeah, it was pretty easy to install, and this does allow you to select a plane on which your helix is perpendicular to that plane, and it also lets you choose the number of points that it's interpolated between, because otherwise it can slow down your machine if you're like me, and because I'm currently working on a laptop, not on a big burly desktop. So the way I ended up getting further into this spring thing is actually using what Eugene Pentland made a tutorial on, which is you go into the patch workspace and use one of the tools in there, which makes a helix. It basically you're following a path with a basically you build a ribbon into 3D space. I'll let him. You should go and watch this video. I'm not going to jump in and explain it, but yeah, he did a good job, so I'll leave it. You should definitely. I'll link it. Go and look at his. And what he's able to do is generate a helical path around pretty much any geometry, around any path. So any central path that can wiggle around and whatever you want, you can make a helix around that. And I pinched the generation of that helix from his video. I'm not applying it around any curves or anything. I'm applying it around a straight line because I want to do a compression spring. But it is useful what he showed me. What he showed us, I suppose. I just had this in here because it's just another example of these are valve springs for the top of a 3 or 3.6 litre V6 for a car, and these are ovoid springs. So these are springs that don't have a circular cross section. They've got an oval cross section, and that's because it allows the spring to compress further down in its motion. If you have a circular spring and the two circles they can come into contact if the spring gets compressed too much. So yeah, another good reason why just the good old coil command doesn't currently cut it. This is kind of the gold standard in my view. It's a sorry, I don't really want to close that tab. This is the tool that's in SolidWorks at the moment, and it's pretty user friendly. There's still some features that I would think are missing from it, but it's definitely a step up from what's currently in Fusion. You can, instead of doing just one or two coils and then join them together, you can have a variable pitch coil, which you can have as many turns or as few turns as you want with fractional, you can go around a quarter of a turn with a pitch of yay much, and then a quarter of a turn with another pitch yay much, and then do 50 turns with a way different pitch, and it'll all smooth it all out for you, and it's all lovely and nice. So yeah, you can see here this guy's example has 2mm pitch for 0 turns, and that's his flat end, and then he's got 1 turn at 8.5, and then he's got 2 turns at 12, and then he's got another 5 turns at 12, and along he goes. So yeah, you can build pretty complicated helixes in SolidWorks at the moment in a way that's way quicker than in Fusion. Yeah, so this is a spring that I looked at last week as an example of a spring that's got some non-standard geometry that might be a little bit more complicated to build, and you could build this using the method that I outlined last week, but I also wanted to find a way of I'm still interested in animating springs and having them move, in either an animation or a motion study, or just by dragging things around in the workspace have the spring actually work, because you can do all of those things right now in SolidWorks, what I'm more familiar with. But yeah, there's a couple of steps that are just missing at the moment from Fusion to do that. Anyway, if you have a look at this geometry and you look at what I've modeled at the moment, they match pretty closely. I'll just drag this to the end and let it compute. But you can see what's on the screen now is an intermediate step, which is what that Eugene guy explained how to make. Oh, my laptop's struggling to do this recording and make this at the same time. Oops, that's not right. Oh well, change some parameters. Wire height, outer diameter, active coils. Interesting. Outer diameter, 40. There we go. Okay, so you can see I've got this fully parameterized, and I've also got the number. So this is pretty much most of the numbers that you'd need to define a spring. For a normal closed-end spring, your number of closed-end number of coils would be 1. If I put that in, then you can see it looks just like a normal spring. And yeah, you can put in spring length. I can change that. If I change that to 100, then it'll get a bit longer. Yeah, so you can see fully parameterized spring that looks pretty good. It's got a nice little trim at the bottom here. It still only has 2 pitches, which is the closed pitch and the central pitch, and that's why this appears to be quite sharp. I could put in more intermediate pitches, but I can't be bothered, and this looks pretty good. So the way that the easiest way I can see of getting, I'll go to the motion study animation part first, and then I'll come back to actually showing you how I made this. But the way that I think it would be easiest for Fusion to make this an animatable thing is to use the motion study instead of just being able to input joints into motion studies. Have a method by which you can update parameters during a motion study. I think that would be really useful in that you can start to use, so for instance I would just have either a motion link or just an equation of some sort that links steps to parameters. So say at step 1, at time step X, my spring at 100 mm, it starts to compress, and at time step 11 my this parameter will have worked its way down to 85 or 83 or something, and then it'll compute all the time steps in between that and keep generating it, and then associate that with a video file or whatever it is. So yeah, so that current main request is make 2 things actually. Make derived dimensions able to be used in parameters, and then also what I said before, which is make motion studies able to update parameters on the fly. That would both, you could, I think that would solve all of my animation sorts of needs. But yeah, so now I'm going to talk you through how I made the spring. I'm not going to actually do it. I'm just going to step through the sketches, show you what each one does, step through all the features, all of that, and then I think that'll give you a pretty good idea of what's of how to go about making this. And I'm happy to share this. I'm not actually sure how to share models like that in Fusion yet, but if you want it, I'll include my email address for this account in the description, and feel free to let me know, and I'll share it with you however we're supposed to do that. Yeah, so I'm going to leave this as it is for now, and I'm just going to roll back to where there is almost nothing in this file. So if I roll back to my original sketch, I'll need to keep turning on and off things as I go because I've hidden lots of things. I started with a couple of just plates, and the thinking here was that I would then be able to put to build whatever I wanted around this, and use those flat surfaces on the plates to make joints, or just have them be some nice flat surfaces on which I can grab joint origins from. So if I jump into that sketch, you'll see it's fully defined by all of these dimensions start with fx, which means that they are functions based on parameters. So I've just made and the reason I've done this is because if I said my spring is going to be 200 millimeters wide, and it's going to be a really fat spring and it's going to be used in some huge industrial application, that the plate on which it sits and I grab the joint origins from, I want that to be roughly the same size as the spring, just so I don't have this huge spring and this little tiny plate in the center that I'm using to grab joint origins on. So I've just used the outer diameter of the spring for that. I've used that just disappeared. There we go. I've used the spring thickness for this, and I was using that as a trim command at the end, but I ended up actually doing a separate trim for reasons. This one is the spring length minus half of the wire height, and that's so that you would think that the distance between these two plates would be just the length of the spring, but I haven't done that because how the lines are defined and things, and because I'm not using these plates in the way that I thought I was going to initially, that minus 0.5 is actually the amount of spring that is sort of left over after the grind. I've said that there's a quarter of the spring thickness left at the end of that grind. So if you go back to this image, you can see here that maybe there's a better one that I can quickly bring up. Ground, closed, springs. The end of it doesn't actually go to 0. It retains a little bit of that thickness. Where's a good image? Maybe this one. Yeah, you can see it doesn't. The spring thickness doesn't tend to 0. It actually just terminates. There we go. That's a good example. So you can see it gets sort of 2/3 of the way around the spring and then it terminates. So I'd say there's probably about it gets 3/4 of the way around. So I'd say there's probably about 25% of that spring thickness, that wire thickness remaining. So yeah, that's that half. That half there is 2 times what's left over, and hopefully that made some sense, but you'll see it make more sense as we go forward. So after that, I just generated the plates. I'll start hiding some stuff now, and I just grouped those into a selection group, and then I started making some more sketches. So first I made these two lines here define the closed end centers. So these are the little center lines that define the center of the helix for the closed ends. So yeah, at the then from those sketches I pulled through the geometry from the bodies, so from these 2 components now. Yeah, so there's my bottom plate. I pulled through the geometry from there, and then I defined these center lines based on those, and I used the wire height times the number of closed end coils times 1.01. So the wire height, obviously you need 1 wire height difference, so that when you wrap the wire around it doesn't clash with itself. And then that 1.01 is just so there's a very small gap between the two wires, the 2 layers of wire, so that they don't touch and create a point or line volume geometry intersection thing that the modeler, the modeling solver doesn't like. Oh yeah, there was also another little thing in there. So that just defines that there's half that starts halfway below the base of that plate. Yeah, so I'm going to stop that sketch now and move on. So this is an axis definition, and I'll use that later, but just know that it is halfway along the spring in the middle, perpendicular to its center axis. Now I defined a plane which is on the end of one of the closed end coil center lines, and I used that to generate the line that gets swept around and makes the helix. And that, if you go back and watch, I forget his name. What was his name? Eugene's video. You'll see the line geometry I'm talking about. It's what gets turned into sort of this ribbon geometry, and then you extract the helix from that ribbon. But yeah, so that's what that sketch is. Yeah. So the other thing is, you define two lines on planes associated with both the closed ends and with the main body of the helix. So then we'll go ahead and create the first helix. So it's easier to explain like this. I know I haven't been that clear yet, but if I hide these bodies and I'll show you. Here we go. So that line segment there is drawn on the plane that sits at the end of this little center line, and then we use this coil. Or what's this called? This is called a. Let me jump in the patchwork space and see. It is a sweep. Yeah, so it's a sweep of a line, and that creates this sort of 2D ribbon geometry. So yeah, if I edit this, you can see I've used a single path sweep, and the profile is that little line segment, and the path is that little piece of line there. The twist angle is the important bit. That's 360, but that's actually defined as that isn't actually defined as a number. And Fusion does this sometimes, and that's actually a formula, but it won't show me what the formula is. That's 360 degrees times how many coils I have, how many end coils I've got, which is that parameter input. I'm just going to check that actually works now. Just check that it hasn't broken it just because I've gone in and kind of edited that sketch. No, so it still works. So you can see that it's actually going around by 720 degrees, even though it said 360 in that box, which isn't that clean of a way for it to work. Probably something to improve on. But yeah, so say now if I go jumping back into that feature, it'll now say 720, but actually that's a formula, but you just can't see it. Yeah, so just so you know, I wrote in there 360 times whatever my parameter is for the number of coils, at the number of closed coils. Yeah. So next I generated this other ribbon, which is generated from this line, which is just a projected version of that line, and that line starts on a plane that's built on this point here. So yeah, so let me main coil center line. So there we go. So these are the two pieces of geometry that define this coil, and also the number of active coils, which is another input parameter. There we go, active coils 4. And yeah, so that's defined in the same way. It's 360 degrees times the number of active coils. Alright, so then I do a circular pattern, and this is why I generated that axis, because this coil is just a circular pattern of this coil, and it's not mirrored because otherwise it would be spinning the wrong way. But yeah, so it's just a revolve. Well, it's a circular pattern that then matches up this to this, and this surface to this surface. And I wanted to try and make this, so you can imagine that this only works because I've got whole numbers of revolutions on the center coil. So you can imagine if I had 3.2 rotations on the number of active coils, which does happen in springs, then this golden surface would end somewhere here, and this wouldn't join up anymore. It would actually end here, but at this height. And I wanted to build in the smarts to be able to accommodate that. But what actually stops you is that the move command in Fusion at the moment doesn't allow you to do either a 360 or a 0 degree rotation, and that makes sense because that isn't a move. But it means that if you want to put a formula into the move command, and it might have it has a rotation amount that is somewhere between 0 and 360 degrees, and you happen to land on one of those values, it will error out your move command. So I can either generate springs that have a non-0 or non-360 degree number of rotations, or I can have whole number rotations. So to my mind, it would be easier and kind of more stable if they just allowed 0 degree rotations. So or said like a 360 degree rotation is a 0 degree rotation, and make a 0 degree rotation allowed. That would be great. So then next step is I just stitch those two surfaces together, and that body is hidden. So there it is. So now all the gold and silver surfaces are the same. The gold and silver represents the two sides of the ribbon, but Fusion's clever enough to make them the right side when you stitch them together. It has when you do the stitch, it shows red and green lines around the edges to show which lines are going to be joined up. So you just make sure the red and green are facing the right way. I then put a little radius in, so all of that happened in the patchwork place. So that was the modify and the a stitch command that happened in here, and so was this revolve. That was this sweep. Sorry, not revolve. And then I jumped back into the model workspace to then apply this radius. And ideally, I would make this radius really, really big, because then that would result in a really smooth looking geometry. But it actually falls over for some reason, and I don't know why. So I've defined that radius as something like 5 times the wire diameter at the moment, and that seems to be pretty stable. But if I was to put in something like 100 times wire diameter, or 1 times outside diameter of the spring, it would just fail. And that might be something to do with this being a helix, and your radius is actually dropping off the edge of the helix or of that ribbon or something. But it's not worth the hassle. It looks fine as it is. Yeah, so I'm just going to leave it at that. I'll show you that what that feature definition looks like. It's just 2 line selections, one at the top, one at the bottom somewhere. Where is it? Probably easier if I change to visible edges. Yeah, that one. Edit feature. So you can see it's selected that line there, and the one at the top. And I'm showing that that line there by holding the control key. That's what shows you what you've selected and allows you to select more or less things. And you can see, yeah, that's five times wire height is how I've defined it at the moment. Okay, and it wasn't important whether I chose any of these things. It all worked the same. Okay, so now what? We're going to the next sketch. So the next sketch defines spring sweep path. So this is what pulls the 3D geometry out of this ribbon that was generated using features. So when I made this, to make this, you just, not being in a sketch or anything, you just go sketch, include 3D geometry. And this is, I don't really like the word include here. I think it's more like extract 3D geometry so you can use it later on. So extract to me is a better word for this, although you do include it in a sketch. So click this button, select which sketch you want your 3D geometry to appear on, which is a bit weird because it's not really on the plane. But yeah, select a plane, doesn't matter which one, and then you just go around selecting the inside edges. So yeah, I'll show you which. If I turn on that sketch, you'll be able to see which ones are selected. So yeah, I've selected this sketch, that this line ends here, and then I've selected this line, and that line ends there, and then I've selected this line, and that line ends way up here, and then selected that line, and that line ends there, and select that one, and that takes us to the end. Yeah, so then I can hide this body, and you can see that's pretty much it. Like, we have generated the line along which we want the profile of the spring to be applied along. The rest of this is just generating parts and doing the actual sweep, which I'm sure is relatively comfortable for a lot of people. This is the generation of the plane on which I drew the profile for the spring, and I've stuck with a circular spring at the moment because it's the easiest. So you can see there, that's my spring profile, and then I do the sweep, and this might take a second to compute. There it is. So you can see it's still it does. So Fusion seems to actually use this point interpolation of a helix, which is why I think that all these lines are appearing on this sketch, which is different to SolidWorks, in that the SolidWorks helix, my understanding is that that's like a vector helix, so it's more of an equation based thing rather than a whole bunch of points that then are interpolated between. That interpolation obviously includes, you know, an equation, but I think, you know what I mean, like this is sort of a digitally defined helix, whereas the SolidWorks one is more like a it just uses its parameters to define the full helix. That's my understanding anyway. Not sure if it's right. Next thing is, what is this? Sketch 14. Oh yeah, this is just the trimming, same as I did last time, but yeah, this I'm sure will be defined by the I actually can't remember how I did this. Yeah, that's just spring length definition around the center point. I'd apply a small offset to make up for the offsets that were applied back in this sketch. If you remember that one, it looked like a very similar sketch, but it had, you know, the half L. It had spring length minus half of a wire height. So that's, I believe, the quarter here. So 2/4 make up that original half. And then this is just 2 times wire height. So that defines both the cut, and it also defines a plinth that I, or plate or whatever, that I added later to make that to mean that I can apply the types of joints that I want to. more easily to the spring. So yeah, I then also just did an extrude to make, yeah, there we go. That's what I was just talking about. Make those parts. I just go through defining some components, and then what else? Oh, this is a different way I was creating this helix, so don't worry about those three things. And then I just grounded and made a rigid group. So that explains how I made a parametric spring. So actually, now that I've got a whole bunch of sketches and stuff, I'll turn these off, but I'll just chuck in a whole bunch of different values for those parameters, and we can see how the spring reacts to that. Keeping in mind that, again, I'm running on a little laptop, and this is a bit computationally intensive. Actually, a good way to do this is to just bring it back to here, and then modify my parameters, and then let it regenerate. It's not quite as fun as seeing it regenerate on the fly, but it's quicker and easier. So let's make a really big spring in comparison to what this is. Let's kind of model it around a car shock or something. Outside diameter, make it 50. Wire diameter, let's make that 8. Let's make the number of active coils 5. The number of closed coil, let's make the length pretty big. Let's make this like 280, and the number of closed coils can be 2. That seems fine to me. So yeah, you can see this thing's quite a lot bigger than what we were dealing with before. And then I'll just drag this out, and we'll see if it likes the if it's all good. Nothing falls over. I don't think it will. I've found that most of the time when this thing falls over, it falls over back here somewhere. So yeah, that worked pretty well. It looks pretty crappy with the with these lines on it, so visual style looks much better. It's just shaded. But yeah, you can see that regenerated fine. Looks pretty nice. Yeah, I wouldn't be too worried about putting that on my car if I had to. Let's make this active coils a bigger number, because the only thing I don't like at the moment still is actually how acute this change in pitch is. I wish that radius was able to be, that radius that smooths it out was able to be much bigger, but you know, win some, you lose some. Radius, number of coils, I'll make that 10. Let's see what it does. Let it regenerate. My poor computer. Hey, we've fallen over. Okay, and I know why, and this is also something that I think can be improved upon. So when you see here, this body 21 has shown up. And the reason it's shown up is because when I'm updating the parameters and the Fusion engine is going back and regenerating all of this stuff, it actually renames the body that so this body is created back here, and it renames the body something new because it's for some reason body 20 now existed at some point, but because I've regenerated the model, something is triggering it to make that body number index, and because this, you know, make this body a component points at that body name, it falls over because it doesn't have body 20 anymore. So it's really easy to fix. Like, you just edit this feature, click OK, edit this feature, select the spring, reselect the spring because body 20 doesn't exist anymore, press OK. So there's nothing wrong in like the stability of the calculations or the stability of the geometry. It's just a naming error, which is a bit frustrating, but as you can see, it's pretty easy workaround. Yeah, so as I said before, totally happy to give this model to anyone if you're making something cool, like if you're modeling motorbike suspension or something sweet, I would be more than happy to give this to you. I'd love to see this in someone's sweet model. Yeah, and next time I'll hopefully make something more, you know, interesting than a spring, because springs are pretty boring. But I've been loving them at the moment, so yeah, I'm just going to save that and call it a day. So video number 2, locked down. Let me know if you liked it, because I'm still unconvinced whether I'm going to keep making these. Yeah, let me know.